In today's class, we will be learning Java file operations. So why do we learn Java file operations and what does that mean? So there is a package in Java called java.io package, which is responsible for all the input and output operations in Java. So there are various APIs in Java which we will be using for file operations. So there is huge set of APIs in Java, and every API has a different purpose. So you do not have to go and learn all the APIs, but we will be going through some basic APIs or a few APIs which are most you can say frequently used. Okay. So before starting with the Java APIs, let's see how the APIs are, differentiated under various categories. To file operations, what are we reading and where are we reading from? Okay, so we have two types of memory. So we have primary memory and then we have secondary memory, right? So file operations means that you are basically reading from the secondary memory, which is basically your hard disk. You're reading from the hard disk. So whatever files which are saved on your hard disk. So if I open my file system, these are the various files which are stored. So I can use a Java program to open the file. Open the file doesn't mean that it is opening in the editor. Opening the file means it is open for reading the content, then read the content and probably then do whatever you want to do with the content. So as a QA, when you will be writing your Selenium scripts or some other test scripts, you would be needing some sort of test data. For example, let's say that you want to test a particular web app. So let's say you want to test google.com, right? So when you test google.com, so probably like you would be testing with, let's say this is your home page, and you would be writing some keywords to test, and then you have to, let's say I test here white box testing, okay? Now when I type here white box testing, so tell me different types of test cases which I can create with this Google web page. There must be certain set of keywords which you need to test, right? So those set of keywords might be in a different language, or probably you can say in English language, different. It could be a whole sentence which makes sense. It could be a word which is misspelled. So there could be couple of test cases. So where you would be writing the test data, you cannot remember the entire test data in your mind. You have to keep it and jot it down on a piece of paper in a document, right? So that is your test data. That test data includes the input data. Okay. Now let's say when I tested for white box testing, I am expecting these 10 you can say matching keywords popping up, right? So this is also again this is your expected result. So you have input and then you have the expected result. So that again is a part of the test data. Expected result. Okay, so this is one type of test data. So your test data not only contains the input data, but it also includes the expected result. And usually in a company, we have different data sources where we keep this test data. So there could be, .csv files, we have .properties files, or we have some, some .config files, or we have .excel sheets, so we have .excel, or it could be .doc, but generally we don't use .doc directly, so we use instead of .doc we use Excel, or it could be JDB. So these are various sources of data, but yes, these are the files that would be used to store that data. In properties and config files, generally we write the configuration details, like server configuration details, URL configuration details. If you want to, test on a particular browser, those kind of details you can
set here, username and password to connect with the database, or username password to connect with the application, right? So those kind of details might be there in your dot properties and dot config files. So every now and then you have to actually write a program to read these types of properties files. So in today's class, we will study certain APIs which will help us to read these types of files. Now, all these files, these files can be categorized into two broad categories. So their first category is character-based files, and then we have non-character files. So what does this mean? Character-based files are those files that can be, in layman terms, you can say that can be read in Notepad, because Notepad is an application which reads only character-based files that can be read in Notepad. So what are these files? These could be .csv. So we can open .csv file, .properties. You can read .txt files, .xml files, and .config files. All these files have are character-based files. So you can open in this double-click and open it in Notepad, and you can read. What are non-character files? Non-character files are files which are stored in some binary format and can only be understood by a specific application. For example, if I want to open .doc file, I need Microsoft Word, right? Can I open a .doc file in a Notepad? No, I cannot do that, because .doc file does not contains only characters. There are certain. It is basically saved as a binary format. If you try to open it in Notepad, it will show you some junk characters. You can go ahead and try and open it in, Notepad. It will really show you junk characters, or it might not even open. Similar is the case with .excel sheet. You need Excel to this program to open and read what is the data which is stored in .excel file. So there is a different API which is used to read the character-based files, and there is a different API to read the non-character files. Okay. Now, before moving on to the different APIs, let's see what do you mean by stream. A stream means flow of bytes. Okay. So what happens is that when you are reading from a file, there is a inflow. So you can say there is an input stream, means inflow of bytes. Inflow of bytes means reading data from a file. Okay. When you say outstream, that is outflow of bytes. Outflow of bytes, that means you are writing data onto a file. That means using a program, I can create a .doc file. I don't have to use Microsoft Word. I am just using some Java APIs to create a .doc file. I can also use a program to create .csv file on the go. That means while running the program, I can create a file, right? So I don't have to, so these are the various streams, or you can say APIs, which would be there to read the file and to write the file. Okay. Then we have, as I've told you, that there are character-based and non-character-based fields. So there are, so you can say character streams and there are byte streams. Although there are other different types of streams also, but the broad categories are character streams and byte streams. What are character streams and byte streams? Character streams are used to read data from character-based files. Byte streams are used to read data from characters as well as non-character files. Okay, so the you can superclass for the byte stream is input stream, and this is the, and for the output we have output stream. So you can search for this input stream Java. So I can show you the hierarchy. So this is the class input stream, which is the superclass of all the byte streams. And there are different subclasses. So we have file input stream, input stream, object input stream, pipe, stringed buffer input stream. So there are so many subclasses which are extending this class input stream. Okay, and this is an abstract class. So a lot of times, people might be asking, have you used any abstract classes? So you can say, yes, I have used, input stream is an abstract class which has different implementations. So these are the different implementations of input stream. Similarly, we have output stream. Output stream, so the common implementation that you will be used would be a file input stream or object input stream. And for output stream, we have file output stream, and we have object output stream. Okay, so these are the byte streams. So what does byte stream mean? They read and write each byte from and to and from the file. So let's talk about just input stream first. So you can correlate with the output stream also. So byte stream read 1 byte at a time from the file. Okay, so let's say this is a file. Let's say basic Java program.txt. I want to write a program which actually reads every character of this particular file, and I want to display on the screen, or maybe I want to do some other programming. I want to read the text data and use it somewhere else. So the main job is to read the data from the file. Okay, so byte streams read 1 byte at a time from the file. What does it mean? So your program, your API, what will the Java program will do? It will go and open the stream for reading. Then it will read the one byte and store it in the memory. Then it will read another byte and it will store it in the memory. So because your program cannot directly operate on the data which is on the file. It has to bring the data into the memory to do the operation. Okay, so it has to reading the file means reading the data from the file and putting it into the memory. If you see this, even this file, when I am not opening the file, it is on the hard disk only. When I double click and open the file, that means it is this application is in memory, and so I have opened the file and placed the content in the memory. So that's what we will be doing using the Java program. So it reads 1 byte at a time from the file. If you see this, this is reading 1 byte. That means 8 bits at a time, not more than that. Okay. Then we have output stream. Again, output stream writes 1 byte of data from the file. So what? So let's say I want to write student scores. So I'm calculating. My program is writing and creating a file, and writing student scores or something. So whatever I'm doing, it would be writing in the form of bytes. Okay. Then what is the difference between it and the character stream? So character streams, the parent class or the super class of all the character streams is reader and writer. And the subclasses that you will be using is file reader, and then we have file writer, print writer. Okay. So these are the APIs that you would be using to read the character stream. So what does character stream mean? Character streams read a character at a time. Okay. So how it is different? So in Java, can you tell me like how many bytes does a character take? Although all these low-level operations are at byte level, it is reading. It reads 1, or you can say it reads 2 bytes, converts them into a character, and returns a character instead of a byte. So let me show you the API for this. So let's say file input. I think I can show you here also. If you see this dot read operation, this is the read operation available for the input stream. It reads the next byte of data from the input stream. And let's see the reader API. Reader API Java. And if you see this dot read reads a single character. Single character means it is reading 2 bytes at a time. So this is the difference between the character API and reader and byte streams, character streams and byte streams. So it returns and the integer value or the ASCII code of the character which is being read. And here what it returns. Here it returns the byte. So the ASCII code of the first byte which is being read. So it is always between 1 to you can say minus 127, minus 128 to 127. That is the maximum, the int range which would be returned from reading the byte. So let's demonstrate using Eclipse. Whenever you read from the characters, so there are, certain nice, so here you are reading the characters. So what happens is, whenever you are dealing with the character-based files, you should always use Reader API, which is a faster way to do the conversion, because the API itself is giving me the converted character. But when I use the file input stream to, let's say, file input stream can also be used to read the characters, but then you have to write your own code to convert the byte into the character. So that's the only difference which we have. So if it's a character-based streams, use the reader API rather than input stream API. So let's write a program here. So I'm creating a new package. And here I'm creating a class. You can say file operations. So I am writing a method. This method reads a character based file using we can say using byte stream. So what is the byte stream? So byte stream is input stream. Okay. So I'm writing here public int read a file using byte stream, and I need to give the file path. So I'm just passing a file path. I want to read how many characters are there, or you can say how many bytes are there in that file, not the characters, bytes. So return count. So now what I'm doing here, so I will be writing input stream in is equal to new file input stream. File input stream. Okay, and then we have to import the package. So input stream is the abstract class, and this is the file, this is a subclass which is implementing this abstract class, extending the abstract class, not implementing. And then since it is checked exceptions, if you remembered my class, all the file operations, they throw checked exceptions. So it throws file not found exception. So you can surround with try catch block. Okay. So you can write here. So once it stops read, you can say in.read, it actually returns -1. So you can write here int c, and c is equal to, so you can say while c is not equal to -1, and it read also throws an exception, which is IO exception. So you can add a catch clause here. Okay, and just to keep on incrementing, right? So you can write here, you need to increment the count, right? Count plus plus. So what we are doing, we are just reading every character, the next byte, and we are incrementing the count. So you can say read bytes from a file. Okay. So I'm just reading the bytes, how many bytes are there, and I'm just incrementing it. Now once you read all the bytes, you need to close the file stream. opening the stream, when I write a statement like this, file input stream, this statement opens the file stream. Okay. Now I need to close the file stream, so I would write there in finally block, because if you remember, we said that we always need to close the file handle, so it should always be there in dot. I would be writing here. Let's try to, since I need to use it in try catch, so I'll initialize it outside the try, and in is equal to this, so I would say in dot close. So this is going to close the out input stream. But for some reason, let's say the exception happens here. So this in will be null. So I have to first check. So if in is not equal to null, then do in dot close. And in dot close again throws an exception, so you can put it into a try catch block. Okay. File operations test. And here let's first create the object of file operations. And then we can call ex.read bytes from a file. So here I'm going to give the path. So say file path is equal to, so let's say I want to read the file from some directory. Okay, there it's a long file. Let's see, there's something. Okay, so we'll go for abc1.txt and just copy the file path. We are copying using the absolute path. And since backslash is used as a escape character, so you need to put a double slash instead of one. And what does it return? It returns the count, right? So if you see this returns the count. So you can say this out. The number of bytes is equal to, so I'm just calling this method here, and then I'm going to run this. So it says the number of bytes is equal to 8. So this, how long is this file? This is basically 8 byte file. There are just 8 bytes. The size of the file is 8 bytes. And let's see how long is abc.text. So this abc.text has 87914 bytes. It's a long file, right? And if you want to you just print the characters, so just make here, if you see, this is the ASCII code, right, of the byte that has been copied. So you can actually, if you want, this out, see, and let's abc1.txt. Okay, so if you see this, these are the ASCII code for the characters which are there in the in the file, right? So if you see this will always will lie between, it would be less than 127. Okay. And if you want to print the character, so what you need to do, convert this into a character. So how do we convert the int to a character? We have to explicitly cast it. Can you see this? A is equal to 1 space. So let me just say dot print. Okay. So if you see this, A is equal to 1, B is equal to 2, these are the characters from the file, and the number of bytes is equal to 8. Here, like, we did not have to do the conversion because all the bytes, the characters which we copied were less than, the ASCII code was less than 127. So, but there might be some characters in the file whose ASCII code is more than 127. Then we cannot just do, explicit casting and then convert it to a character. Then we have to read 2 bytes and then convert it into a character. So if you have a character-based file, it's better to do what kind of API. Instead of byte stream, we can use character stream. So I'm writing the same program, but I would be using the character stream. So let me just quickly change this. And here I would say read bytes from a file using character stream. So instead of input stream, I would use file reader. And here also I would use file reader. So file reader is a character-based Java API to read character-based files. Okay. And okay. And let's try to call this. Okay, so here the number of characters is equal to So let me just walk through this. Initially, the count is 0. I am initializing the file reader class, and this is the reference variable as null. So I'm creating an object of file reader, and this is the path of the file which needs to open the file. I'm opening the file stream. Then again, in.read is here. It's going to read the character. So here, this integer is basically the ASCII code of the entire character. So it is 2 bytes, and you are reading the number of characters in the file, and you are printing the character. Okay, so let's try to run this again. And let me just instead of this, again I have to. So again, the number of characters is equal to 8, and since I don't want to print the ASCII code, I want to print the actual characters. So let's do this again. Okay. So the number of characters is equal to 8. So how come the bytes and characters here are same? Because all the characters which are used here, they are their ASCII code was less than 127. So it really doesn't matter whether you are using file stream or character streams. But if your file has a certain special characters, so then this will show different results. Okay. So what I'm trying to say is, if you want to read from any kind of a character-based files, means if you want to read from a CSV, from a properties, TXT, XML or config, what type of API do you need to use? Stream, byte stream or character stream? Excel sheet or a doc file, then you can use or any other file. Not only it will read from these two, it can read from any other file which can be read, and it can file input stream. So let's try to read it from some other type of file. So let's give another file path. And let me see, I have any doc file here. Okay, let's see cur.xls. Okay, so cur, this is file path. So the first one is I'm reading a byte stream. Second one, I'm using a character stream. So I'm using a character-based file. I'm just trying to read the number of bytes in both the files. So let me just, it might be a long, big file. So, okay. So if you see this from Excel sheet, the number of bytes there is 19456. So you can actually see the properties. So if you see, this is almost, the same size. So the size which is on the disk is almost the similar size that your program has read, right? So this is the file size, and this one we were looking at, right? So 19456. So this is almost the same. 19456, exactly the same, right? So 19456 number of bytes are there in the Excel sheet, and the next one was a character-based file, and it has 8 bytes. Okay, but we cannot use the same API to display the characters here, because the characters here, if I try to open it in Notepad, it will give me junk characters. So I will not be able to read the characters of Excel sheet and display on the screen. Okay, because there are some other characters apart from the data which is stored in this Excel sheet. Is this clear? Just like we are reading from the byte stream, we can actually write on a character stream. So let's say I want to create a file. So let's write a program. So this method creates a text file. Let's say I want to create a text file using character stream. So what is efficient? So definitely if I'm using a text file, so character stream should be more efficient to create, right? So let's write a program, public void create a file using character string. So this is the file path. So what I'm doing, I'm using the file writer API. File writer, say fw is equal to new file writer path. And instead of direct path, you can actually use create a file object and then pass the path. Why I'm using this, I'll let you know. And again, file writer is throwing the IO exception, so I need to catch it with the try catch block. Once I open the stream for writing, so here I'm opening the stream for writing. Okay. And okay. Now I need to write here something. So we have, the method called write. So you can write a string, you can write a character. So say hello world. Okay. And once we write it, we need to close it, right? So how are we going to close? Again, we have to put it into finally block. So let's take it out of the try catch block. And then we need to close. But we have to first check this. If fw is not equal to null, then fw dot close. And again, we need to put it into try catch. Okay. So I'm creating a file and I'm writing hello world into that file. So let's call this in my test method. So I'm creating a demo1.txt and let's call this ex dot create the file. Okay. So once it is done, it can write here, file created. So I can write in finally, or I can write here, this out, file created. So I need to write it here before closing successfully. And in the catch block, you can actually write file could not be created. Okay. So let's run this. Says file created successfully, and let's see whether it has been created or not. So we'll see demo1. So demo1.txt, and it is written hello world. Okay. So this is how you can create a file. You can actually write a couple of other things. So file writer API is not a very, you can say, API which is, you can write all the characters. Here only you can write strings and characters. So there is another API which is called print writer, which can be used in conjunction with file writer. So you can write here print writer PW is equal to new print writer, and it has the file writer object here. So this is a convenient way to write different types of objects onto the file. So here you can say pw.print. If you see this, you can write a boolean, you can write a character, a double, float, whatever you feel like. So let's say, I can write and you can use println as well. Let's say I want to write some score. Okay, and let's run this again. So here I'm just using print writer API, and I can use println. So what is the difference between print and println? Println writes in the next line, the next whatever you want to write is going to write in the next line. So it appends end of line character at the end. So let's run this. If you see this, these two objects have been written onto the file. Okay, so this is how we use file writer along with the print writer, and it is used to create the text file. If you want to create a binary file, which is highly unlikely probably in your scenario, but there you can simply use, instead of input stream, you can use output stream, and instead of read, you can use write and write a character onto the file. But okay, then let's move on to some other streams which are very popular streams. So now if I'm trying to explain, so as I said that we have byte streams and we have character streams, right? Byte streams read a byte at a time, character streams read a character at a time. Reads a byte and this reads a character. Okay, so let's say a file contains, let's say 8 characters, right? So byte stream would, how many bytes are there? That means it is 16 bytes, right? 8 characters means 16 bytes. So when it is reading the 16 bytes, there would be 16 IO interrupts. IO interrupts means, what does IO interrupts mean? Your Java program is going to hit the hard disk 15 number of times. Similarly, when I'm using character streams, it's gonna again read 16 bytes, 16 IO interrupts. But here, what just the advantage is, it returns, it automatically converts the first 2 bytes into character and displays. Okay, so now if your file has, let's say, it's a big huge file. So there are so many bytes in the file. So there are so many interrupts. So every IO interrupt is a costly process. Interrupt is a costly process because it is slow. Reading from a file is always slower than reading from memory, right? Is slower than reading from the memory. Why is it so? Because reading from primary memory, when your program is running, so a lot of times you must have seen, if the file is already open, it's easy to scroll it down, right? Because it's already in the memory. When you open open a file fresh from the hard disk, it takes time because you are reading from the hard disk. So it's a costly process. So what does Java does? Java provides another set of streams called buffered streams. Buffered streams. Buffered streams read the bytes into buffer, which is a special memory area, which is a memory area, and then the Java program reads the data from the buffer. So in one interrupt, it reads the entire buffer, like it not only one. So what happens in one interrupt? It reads a chunk of bytes and puts it into buffer. So so this would be more clear when it can be. So whenever you see a video, let's say you are watching Netflix or you're watching YouTube, it always keeps saying I'm buffering. Buffering means it is reading the data and it is storing in your in your memory. Okay, so once it buffers, it's faster to play that video because it is reading from the memory rather than reading from the server. So it is buffering. Okay, so even if you might have noticed, like a lot of times, when you're watching Netflix, even if your internet goes away for a few seconds or few minutes, the still stream goes on because it is reading not from the server, it is reading the data is coming from your local machine. That's the reason it is that buffering is always faster. So in short, buffered streams are always faster. Okay, so what it means to say, let's say you have a file which is you can say which has 2048 bytes of data, right? Now the time taken for characters, say for file reader or you can say file input stream will be, so how many interrupts will be dependent on 2048 bytes of data, right? So many interrupts would be there to read because it reads just 1 byte at a time. The file reader reads 2 bytes and file input reads 1 byte at a time. So it's a slow process. Let's say we have a buffer of 1024 bytes, which means your program is reading 1024 bytes in one interrupt and storing in the buffer. So we need only 2 I/O interrupts to read the data, entire data, right? Do you understand this? Right, reader and file input stream, they are, so byte stream and character streams are low level APIs. Low-level APIs means it is talking to the hard disk and read it and using it in the program, right? But when I'm using the buffer stream, it is reading the data from the file and it is storing it in the buffer. And then your program is going to read from the buffer to do the any kind of processing on the data rather than reading it from the file. Okay, so that processing is much faster because that processing is from the buffer, from the memory, from the primary memory rather than from the hard disk. So what type of memory is buffer? Buffer means the primary memory. Okay. This method reads data from a text file using buffer reader. Okay. Now, when you are using buffer reader, you can use buffer reader with, because the files might be a character-based file or non-character-based file. So you can use buffer reader with file reader, or you can use, there is another stream called, buffered input stream, which is used to read data using file input stream read. Okay, so this is the a faster way. So this is if you do not want to do the conversion, if you do not want to read the characters or data from the file, you can use a buffer input stream. So buffered streams are used with the file readers, or buffered read streams are used with the this is a file input stream. So you have to combine these two to get the output. So let's try to do this. Public void read data from buffer. Okay, and string path. So I'm using a character space. So I'm writing buffered reader. New buffered reader, and I'm using it with a file reader. And here I'm passing the path. I need to again import the package java.io and put this into under try catch. Okay. Now with buffer reader, we can actually read the entire line of data. So I'm writing here string line is equal to this, and file. You can read character by character also. So if you see this API, so buff.read. So here you are reading a single character and you can read the entire line of text, right? So this is a much faster way to read, right? So let's try to read the entire line. Why? Because where it is reading from, it is reading from the buffer, not from the file. That's the reason it is faster. So while line is equal to buff.read line, and it will keep on reading until it is null. Okay, and here let's say I want to display on the screen, so you can display on the screen also, and you have to put this into try catch. And then again, and finally I need to close the stream. So you can write if buff is not equal to null, and again you have to take it out of the try block. If buff is not equal to null, then what you need to do is buff dot close. Okay, so the same steps, just a little change. We are reading from using the buffered reader, and we are using the file reader for that. And then we are reading the entire line of the code, and we are displaying on the screen. Okay, so let's run this. Okay, so here and let's see what I need to read. Let's pick a file which has lots of data. Okay, so this is some file which has a lot of data, all images.txt. Okay. Okay. So I'm reading this data. What happened? Okay. And let me call ex dot read from buffer, and let me just instead of this, so I'm creating a. Let's say I want to count the line. So count is equal to 0, and here you are just incrementing the counter, and return count. Okay, so this is the number of lines is equal to and here you can use file path 4. And let's run this. If you see this, their number of lines is equal to 14, and the entire file has been read. Okay. So we are reading the file line by line. Now, just to give a good idea, how fast is reading from buffer input, buffer stream as compared to a byte stream. So I'm here. If you see, there is a number of bytes, and just to give you an idea, what I'm doing is I'm using a statement here. So I'm using a system API to get the current time. So if you see this current time in milliseconds, I can use current time in nanoseconds also. Dot nano time. Okay, so this is byte stream. Okay, let me not put this. Okay, and this is your start. I'm writing here long s time. This is my start time, and where I'm just trying to open the file, and this should be my end time, right? Before just returning the count, this is my end time. And here you can write time taken by byte stream. Byte stream is equal to, you can write here E time minus S time. Okay, the same kind of thing I'm gonna do. Okay, S time. Okay, so the same kind of thing I'm going to do is the buffered API, long time, and this is your end time. So time taken by buffered API is equal to E time minus S time, and let me just divide it by 10,000 because it's in nano time. And let's do the same thing here. So when you want to find the, how much time a piece of code is taking to run, this is a way. So in fact, like some of the times in the interviews also they ask, how can you find, how much time my test is taking to run. So in there, while doing automation, there might be some, long tests. So you can use something like this. You can use the E time, start time and end time, and use the system API to get the current time, and then just divide it by 10,000, or you can use, in milliseconds also. So anything you can do. So I'm using the same file for both the operations, and let's run this. So for the, here if you see, this is 547. Number of bytes, if it's the same because we are just reading the same file. And if you see this, the time taken by the buffered API is 210. So this is comparatively very fast. So less than half of the time has been taken by the buffered API. And here the size of the file is still small. And when we talk about, a big files, thousands of bytes, this difference is huge. So always keep in mind that try always using the buffered APIs. So for reading the file, so you can write the buffered API like this. Okay. This is the buffered API. So you read the buffered reader, and then you read a single line of the code, and you can print. So even like if I just, a lot of time is being, written in printing. So just if you just want to compare the print, just to read how fast, you can still see the time is drastically reduced. Like from byte stream, it is taking 170 bytes, 170 milliseconds, and buffered API is 43. So this is more than 4 times of time by the byte stream. Okay. That topic. So we use, if you see this in one of my program, I use this file object. So file object is a very useful object. You can use the file object to find whether a file exists or not. So file object, there are certain APIs like, So let's try to create a file object. Okay. So I'm creating a file. Say my file is equal to new file. Say file path 1. So this file object can be used with okay. Okay, with the files or directories, both. Okay, so you can use, let's say I want to just check whether this file at this particular path exists or not. So I can write here my file dot exist. So it says if my file dot exists, then the file exists. The file is present. So if it returns true, then file present, else you can say file is not present. So let's say you are running a test script, right? And you are creating a log file. And so what happens when you are reading using the file writer API? In file writer API, every time you run this file, it will be creating and it will be deleting the old file and it will be creating a new file. Okay, so let's say you don't want to delete the old file, you want to just check whether it is present or not, so that you can use this file API just to ensure that it is present. If it is not present, probably you want to create a blank file or something like that, right? So you want to do certain operations. So not only for this, it also can check whether the file is a directory or not. So let's say, let's say I create another file object. Say my directory is equal to new file, and instead of the file, I'm actually here writing here directory. Say the users. This is a directory, right? So you can check whether this is a directory or a file. So you can write here my directory, and it says is it a file. So here you can check is whether it's a file or not. If you want to check whether it's a directory, then you can use this is directory. So it says if it is directory, then this out, it is a directory. Okay, else this out, it's not a directory. Similarly, you can you can create a file if you want to, let's say, create an empty file. You can write here something like this. You can say my file dot create new file. It creates a new file. It's with 0 bytes of data. Okay, so whatever file name you will mention here, it will create a new file. Okay, so this is a very useful API. You can go through it. Let me see if I can show you here. Okay, so you can see check whether the file is executable. Like sometimes there are permissions on the file which is not letting you find. You can check whether it has read permissions, write permissions. You can create a new file. You can compare to path names lexicographically. So I have already explained what is lexicographic means. Then you can actually use it to delete the file. So let's say if the file name exists and you want to delete the old file and create a new file, you can use this option delete. And this is for checking whether it's an exists or not. It also tells you, it gets the how much unallocated bytes. I really don't know whether I have never used this. Then you can check the parent, like if you want to check, in which particular directory this file is located, then you can get the parent. You can get the absolute path for that file, so you can say get absolute path. Then you can also get the size of the file. The length means the size of the file, whether the file is hidden or not. So anything related to file you can use with this file API. Okay, and you can actually create directories. So mkdir creates the directory and create a new file, creates a new file. Fine.